Okay, in this video we're going to do a couple of additional examples using superposition. First, we're going to solve a circuit that has a dependent source in it. Noting that dependent sources are a little bit of a special case for superposition. When solving any circuit with a dependent source, we must always remember to keep the dependent source active inside the problem. Otherwise, you could change the functional relationship that is pinned based on that dependent source. So in this case, we're going to find voltage V0 using superposition. And note that V0 appears between these two red nodes highlighted in the problem. So that's what makes this a little bit more challenging than what we're used to seeing. V0 is the voltage across both the 10 ohm and 50 volt source at the same time. And like I showed you in the last video, I'm going to do this using an expedited method where I'm going to set my voltage sources equal to variables. I'm going to call this one V2. The 50 volt source is V2. 70 volt source will be called V1, and I'm going to write a single set of equations and use substitution twice in order to solve the problem. So if I do mesh analysis on this problem, I'm looking at three meshes, so 3 KVL equations. Nodal analysis, I have 4 essential nodes, so that's 3 KCL equations, but I have a lot of voltage sources. For example, if I choose this node here in the center, one of my essential nodes is known, thereby getting rid of one unknown, and 2 of the other essential nodes are a supernode. So I can do this in one equation using nodal analysis. Likewise, if I choose the node on either end of the 70 volt source, I have a similar situation where one of my essential nodes is known, another is a supernode. I'm going to choose this node on the bottom to be ground for a couple reasons. One is I now know this node above the 70 volt source is known, label it V1. But also, the node on the far right is going to be V0, so I'm solving for V sub 0 directly in this case. I'm going to go ahead and label node on the other side of the 50 volt source is V0 plus V2. And I'm going to label the node on the other side of the dependent source as V0 minus 2IB. Noting that that comprises a supernode. So I have 2 sections of the circuit that I need to solve, but both amount to a supernode. Therefore, I can do a single KCL expression at the supernode highlighted here in red. So the KCL at the supernode, first, current through the 20 ohm resistor is going to be given as V0 minus 2IB is the potential there, minus V1 divided by 20. That's the current through the 20 ohm resistor. Current through the 2 ohm resistor is given as V0 minus 2IB over 2. Now looking on the other side, we have the current through the 10 ohm resistor and the 50 volt source. So here I have to take V0 plus V2 minus 0. So V0 plus V2 over 10 ohms. And then the current through the 4 ohm resistor, which will be given as V0 minus V1 over 4 ohms. All that equals 0. So that is the single KCL expression required to solve this problem. Remember, V1 and V2 are actually knowns. I just wrote it this way to facilitate superposition analysis. V0 is our unknown we're trying to solve for. We have an extra unknown, IB, due to the dependent source, so we need a constraint equation for dependent variable IB. Noting that IB is through the 4 ohm resistor from left to right, so that can be described in terms of the nodal voltages as voltage V1 minus V0 divided by 4. So this is our two equations with two unknowns, which are V0 and IB. So we're going to solve this twice for superposition. The first way we're going to solve this is by setting V1 equal to 70 volts and V2 equal to 0 volts. And doing this, you're going to get that V0 star, or due to the 70 volt source, whichever way you want to write it, equals 34.25 volts. We're going to solve it again, setting V1 equal to 0 volts and V2 equal to 50 volts. Get V0 double star, and that's due to the 50 volt source, as being negative 4.26 volts. So finally we find that V0 is just the summation of V0 star and V0 double star, which is approximately 30 volts.